Check. Just a minute, guys. Check. Okay, I feel the noises have settled down now, and we can continue with the class. Hi, hello Venkatesh, hello Vishwa, hi Akshat. Good afternoon, everybody. I hope you guys had a nice weekend and you did memorize the list of formulae which I had given you. All the formulae which had differentiation and integration. Of course, before giving you those formulae, since we are at the, this is the first class of the week. Vish is asking, sir, the fluid stout. Well, Vish, I think I asked you whether you have studied fluid mechanics from DC Pandey. Right now, I can't sit and teach fluid mechanics in a bridge course, but try studying it from this book, DC Pandey. This should give you some clarity. I think you have doubts with the flow state, flow equation, that A1 V1 equal to A2 V2. If you understand this properly, you'll be able to apply this in a venturi meter, where you can eventually have different areas of cross section, and if velocities are different, you can utilize this equation here. And this can come in a lot of cases, like your venturi meters can be of various shapes, not always of a straight shape, but as long as the concept is clear, you can apply the same concept to other topics also, right? Come up with some specific problems. If you come up with specific questions, I'll be able to help you better, because I don't really have the time to sit and explain you the whole theory. If we have a good number of people, like a good number of people who are having the same doubt, then we can discuss that. But since this is a bridge course, people haven't heard of fluid mechanics yet. Never mind, people. Let's come back to what we were discussing. Differentiation and integration. I gave you the conceptual introduction to that, so that you don't blindly sit and just apply formulae to differentiate some functions or integrate some functions. You should know what we are actually doing when we are differentiating a function, or when we are integrating a function. What is the actual need? Because if you lack that understanding, you will not be able to apply that in problems. Okay. Anyways, let's first look at a few functions. Let's discuss some problems actually, and then we will move forward. In fact, even before we discuss some problems, we need to discuss some laws of differentiation, because unless you study these laws, the other set of problems are very basic. Like the only kind of questions that I can ask you right now is, hey, tell me what is d by dx of secant square x, d by dx of tan x. Tan x is there in the list. In the list of 10 formulae that I gave you for differentiation, tan x is a function whose direct formula is available with you. So you can say the answer to this is secant square x, right? But if I ask you d by dx of secant square x, You differentiate tan x, you get secant square x. But if I ask you, if you differentiate secant square x, what do you get? Then you won't be able to answer this because this is not in the list. This is not in the list. What list am I talking about? The list of the list of formulae that I gave you in the last class. I gave you 10 formulae for differentiation and I gave you 10 formulae for integration. So if you get questions or if you get functions which are directly a part of this list, you can refer to the list. Obviously in the exam you will not be allowed with any paper, so you have to memorize it. You will only be able to memorize it if you solve enough questions, right? Then you will not have to sit and blindly learn it like a table. If you understand it and if you apply it in enough number of problems, you will end up learning it even without putting a conscious effort in learning it. So these problems will be there, these formulae will be there with you in your head. If the function is directly from these 10 or these 10, if you are differentiating and if it's directly from these 10, you can utilize that to get the answer. But if you get a function like this which is not in the past part of this list, then what do? Then you will have to take some basic laws of differentiation and combine these laws with the fundamental problems. Sorry, with the fundamental formulae. So basically, these laws of differentiation plus these 10 formulae, these together can give rise to a lot of other formulae, which includes this also. So let's discuss these laws, because without these, I can't really give you any question which is out of this 10 formulae list, because you will not be able to solve it unless you know these laws. Okay. And these laws, there are just 4 laws, very simple laws, but very, very crucial. Again, guys, very crucial, because you will be using these laws. I don't know how many times, so many times. Number 1, d by dx of the sum or the difference of two functions is nothing but you differentiate the first function and you differentiate the second function with respect to x, and then you add these differentials. If you are adding, if it is plus, right, or you subtract these differentials if it is a minus, which means if you have d by dx of sin x plus cos x, then you can do this. First differentiate sin x, then differentiate cos x, then add these, right? And instead of plus, if you have a minus between them, then differentiate sin x, differentiate cos x, and subtract them. Very simple law, but very important. Okay. Sorry, I'm yawning a lot. Just like every Sunday, I had to wake up for quite some time last night because I was working on something, and then I wake up early. I wake up late, and usually Mondays I'm a little tired than the other days. Okay, so this is the first law. Second law, guys. Again, these laws, there is a little bit of understanding, but at the same time there is a little bit of memorization also. Formulae are all about memorization, but these laws are a combination of memorization and a little understanding, right? So if you have f of x into g of x, number 1, this first law is called the sum or the difference rule. Sum or the difference rule. Good afternoon, Tejashree. New name, looks like you're here for the first time. As usual, I believe some students are having their coaching classes going on, which is why they are not joining live. I will have to discuss with my team whether we can reschedule bridge course timings to some other timing. And if I do that, I will announce that soon in the class. Okay, I will discuss it with my team today, whether we should have the bridge course between 12 p.m. to 1 p.m. And then if needed, we will change the timing. And if any of you have an issue, you can bring that issue up when I announce the new timings. Okay, because I want more and more people to come live for these classes instead of watching recorded lectures, and people are missing live classes because of their coaching institute classes. Okay, d by df of f of x into g of x. This is called as the product rule because you have a multiplication of two functions. Two functions are being multiplied here, and after multiplying them you get a new function which is f of x into g of x. So you can clearly see here f of x is a function, g of x is a function. If you multiply these two, you get a new function. When you differentiate that function, how will you get the differential? That's got using this law. First take f of x as it is and multiply that with the differential of g of x. To this, then you take g of x as it is and multiply that to the differential of f of x and add these two, right? Add these two. Again, don't go into thinking how these laws have come. You will not understand these laws at this point of time. There is intense mathematical research that has gone into coming up with these formulae or these laws. Formulae, once you understand these laws, once you understand the basic essence of differentiation, you can probably derive those formulae also. The 10 formulae that I gave you, they can be derived. But right now, you're not in a position to understand that derivation also. So you'll have to memorize it. As far as these laws are concerned, these also, with some intense mathematical steps, which is intense at this point of time for you, but may not be in the future, you can derive these laws also. But right now, our focus is not on the derivation of how these laws have come. Just see whether you understand the LHS and the RHS of the laws. What do you have to take from these laws? Again, see whether you can understand the LHS and the RHS of these laws. See whether you can understand each and every term in the LHS and the RHS. You should have no confusion with what D is. You should have no confusion with what dx is. You should have no confusion with what d of g of x with respect to dx. Like, you should have no confusion what this term means. This term means I am differentiating g of x with respect to x. This g of x can be anything. It can be any of those 10 functions which I gave you in the list, or anything outside that also. Usually in our syllabus, if any function comes outside those 10, then we apply these laws. These laws will cover most of the cases. We apply these laws with those fundamental formulae to get the formula for the new function. That's how it goes. Okay, let's come to the third law. How do you do this? D by dx of the ratio of two functions. What does this mean? f1x is a function which is like sin x. f2x is a function, let's say it is cos x. It is sin x cos x. f1x by f2x, what function is this? Sin x by cos x, or nothing but tan x. So f1x by f2x is tan x in this example. So remember, this box that you see, this box itself is a function. Now, this function is a ratio of two functions, right? So as you can see, of course, the answer to Tejasri, the answer to this question is secant square x. You are right, but the law that I am giving is not just specific to this question. It is specific to anything. Your f of f1x need not be sin x, your f2x need not be cos x, and this law will still be valid. Okay, and the law says, first you take f2x as it is, multiply with that with the differential of f1x.
Yeah.
Then you take f1x as it is and multiply that with the differential of f2x. And then you divide this with the square of f2x. Right? You divide this with the square of f2x. So let's see. I gave you this formula in the list, right? D by dx of tan x is equal to secant square x. I gave you this formula. Can we derive this formula using this law? We can. Let me show you how. D by dx of tan x is nothing but sin x by cos x, right? So this is looking like this fellow is my f1x. This fellow is my f2x. So this and this are looking similar now. So let me apply this law on this. So take f2x, which is cos x as it is, multiply that with the differential of f1x. What is differential of f1x in this case? What is differential of sin x? That is available in the list, right? It is cos x. I have already given that in the list. So cos x into cos x will come. Then what do you have to do? Subtract this, put a minus sign. Then take f1x as it is. What is f1x here? Sin x. Take it as it is. Alright. Then multiply this with the differential of the denominator function. What is the denominator function? Cos x. What is the differential of cos x? What is it? I gave you in the list already, right? It is minus sin x, right? So multiply this with a minus sin x. Okay. Now divide this with the square of the denominator function. What is the denominator function? Cos x. Cos x square. That's all. So what do we have in the numerator, guys? Cos square x plus sin square x. What do we have in the denominator? Cos square x. Right, Tejasri. I don't know why I am pronouncing your name wrongly again and again, because I have heard too many Tejasvis and less number of Tejasvis, so please don't mind. So in the numerator we have 1, because sin square x plus cos square x is 1. You know that by 10th class mathematics, and this by cos square x, right? What is 1 by cos x? Secant x, correct? What is 1 by cos square x? Secant square x. So I can write this as secant square x, right? I'm hiding this. Let me hide myself. I can write it as secant square x. So can you see? We were successfully able to derive it. Like we can derive the differential for sin x using quotient rule as secant. Like we can derive this formula also. I hope you guys understood the whole derivation, right? So this was a specific case where my f1x was sin x, f2x was cos x. But sometimes they need not always be sin x and cos x. They can be anything. And this law can be applied to it. Okay? This law can be applied to it. Also, guys, I would want you to notice this fact here. Let me just quickly rub this and I'll show you what I'm trying to say. D by dx of f1x by f2x, don't think that this is equal to d by dx of f1x divided by d by dx of f2x. No, these two are not the same. Here you are taking f1x, f2x, taking the ratio and making a new function, and you are differentiating that function. And here you are differentiating f1x, you are differentiating f2x and taking the ratio. These two are different from each other. They are not the same. Okay, don't get confused in the notation. Again, very important law, this third law. First law is very important, second law is very important, third law is equally very important, fourth law I would say is even more important, because you will use this law in even more number of cases. See, right now I can't give you that. If I can't give you a number, like let's say you have 100 problems of differentiation in physics, like 100 problems in physics which will require you to differentiate. I cannot say that 10 problems will have first law, 20 will have second, 20 will have third, and 40 will have 50 will have fourth law. I can't give a number, but from my experience, from the number of problems that I have solved over all these years, my brain has been able to identify that yes, this fourth law, which is known as the chain rule, this is used in more number of problems than, by the way, this is called as the division rule, or the you can say this is division rule for differentiation. You can also, this is quotient rule. I don't know, division rule is more apt. You can say this is division rule for differentiation. You can say this is product rule for differentiation. This is sum or difference rule. So from my experience, I can say that the next rule which we will discuss, which is the chain rule, that has more number of applications than the first three. So please continue paying your attention to this one. Very important law. Okay, and this law says that if I have d by dx of f1 of f2 of so on fnx, then that is nothing but okay, let me, instead of writing it as a law, I would rather discuss this as a problem. Maybe some of you might get confused with what this notation is. Let me look at the exact notation. And then we will discuss problems on this. I don't want to write this notation in a way which will end up confusing you even more. Okay. Just a minute, guys. I'm looking for the right notation because in my textbook it's not mentioned as a notation. Let me not put so many functions in the beginning because I'll end up confusing you. Let me just take two. Let me just take two in the beginning. So let's say you have f of g of x. What does this mean? This means, let's say you have a function g of x as x square. Okay. So this g of x is a black box which is x square. You give x as input to this and you will get the square of your input as the output. That's what this g of x is. Let's say you have another function f of x which is sine x. Now, so okay, f of x is this black box, sine x, you give x as input, you will get sine of your input as the output. So far so good. These two functions are individually clear to you. Now what do you mean by f of g of x? F of g of x means f is as it is, but instead of giving x as input, you are giving g of x as input. Okay, that is what is happening. So let me draw it on the next page. What do I mean by composite functions? So f of x was my sine x, g of x was my x square. So my black box is sine x. So if I want to draw f of g of x, what will I have to do? Instead of giving x as input to this, I will give g of x as input to this function, which means my input will not be x, my input will be x square. Which means right before this block, there is another block called as x square. So when you give x as input, you will first have to give it to this block. So when you give x equal to 2, that 2 will go into g of x first. And then the output that you get from g of x, that is fed into sine x. Which means x square, even if you are giving x as the actual input, sine x is taking x square as the input. It's not taking x. This is what I mean by, like, this combination is known as f of g of x, where you will first give x as input, but then it will first get processed in g of x. Whatever g of x releases, that is fed to sine x, and then finally sine x square will come out. So this, if I write f of g of x for these two, if I write f of g of x, it's going to be sine x square. Quick question to you guys. What is g of f of x in this case? Do you think f of g of x and g of f of x will be the same? First, yes or no. Do you think f of g of x and g of f of x will be the same? Do I have anybody who can answer a yes or a no in the chat? I will move once I get a response in the chat box. No, sir. Yeah, you are right. It's different. Okay, then can somebody tell me what is g of f of x going to be here? Use the same analogy. What is happening here? When you have g of f of x, that means you are giving x as input. That x is first getting processed in f of x. Whatever your f of x is releasing, that is going into g of x. And finally, g of f of x is coming out. So if my g of x is x square, if my f of x is sine x, then my question to you is, what is g of f of x? How do you write it? We have seen that f of g of x is sine x square. But what is g of f of x? Can somebody write that for me? If you can't write, at least say no, so that I will get an idea that you're not clear with this, and I will give a detailed explanation. Hello Sujit, good afternoon. Come on, somebody say a yes or a no. Can you write what g of f of x is based on this analogy? Or are you working? If you are working on getting the answer, at least write working in the chat box. You can't write. All right, Akshat. Anybody else? Can somebody write? I believe no. Fine. It's simple. Okay, again, it's not very difficult. Let's see how the whole process is going. I'm first trying to explain you what composite functions are, because unless you understand what composite functions are, there is no point studying chain rule. If you don't know chain rule, you can't solve a lot of physics problems. That's why we are doing this. Okay, so first you have f of x, correct? And what is your f of x? I'm asking f of g of x or I'm asking g of f of x, right? Which means f of x will come first. When you feed x, it will first get, you wrote, Tejashree, you wrote, okay, I didn't see, write it in the chat box. What is the answer? What is the answer to this question? What is g of f of x? Fine, you can write it in the chat box. I'll verify whether it's right or not. Let me first continue. F of x, according to my problem, is sine x. G of x, according to my problem, is x square. If I'm doing g of f of x, then f of x will be on the left side. If I'm doing f of g of x, then g of x will be on the left side. And why? Because I have to see the order in which the input is being processed. When I have g of f of x, I will first give my x equal to 1, let's say, to this. So f of x will first release an output, and that output will act as the input for g of x. Getting it? So you give x equal to 1, first f of x will release your f of 1, and then that f of 1 will go into g of x. So finally you will get g of f of 1 as output, right? Inside this square brackets, I will have the input to g of x. Is this clear? I hope this is clear at least first. So if you are giving x as input to f of x, because f of x is sine x, yes, Tejashree, you're right, sine square x is the answer. So if you're giving x as input to f of x, sine x is coming as some sine x is coming out as the output. If you are giving sine x as input to g of x, then sine square x will come as the output. And why so? Why so? Why is this happening? You might think that this function is x square. The point is, guys, g of x is x square. Whatever input you give to this fellow will square it. So if you are giving sine theta as input to this fellow will square it, because that is, x is just a notation. Remember, it's a notation in this case. If I'm saying x square, it means input square. Think of it as, instead of x square, think of this function as sine of input, and think of this as input square. Now whether your input is x, y, sine, log, I don't care. If you give x as input, you will get sine of that input. So if you are giving x as input, you are giving sine x as output. Here it is input square. So whatever you give as input, that whole quantity will get squared. So you are giving sine x as input, sine will get squared. So you can see it clearly. This is g of f of x, because if f is coming on the left side first, if it's coming first, then it will be inside g of x. Okay, inside. So this is g. So g of f of x is sine x square, but f of g of x was sine x square, sine of x square, and this is sine x whole square. So it's something like, there is sine 2 square, which is sine 4, and the other one, like this fellow, is sine 2 whole square, which is sine square 2. And people, sine square 2 is not equal to sine 4, because sine 4 is sine 2 square, not sine square 2. Okay, so guys, this can get tricky. If you do not understand composite functions properly, this can get tricky. You will not be able to club it properly. Okay, let's test if you have understood this with a small problem. Although I am teaching you mathematics basics now, but it's fine. It's still useful even for a maths bridge course, and you need it for physics also. You kind of need it. So let's say g of x is log x, and f of x is tan x. Tell me what is g of f of x first. Tell me what is f of g of x next, and apply those boxes concept, right? Apply those boxes concept. You should know there is a reason why I have been asking you to treat functions as black boxes, because it helps us understand these things better. Log of tan x. Tejasri, what is log of tan x? Is it g of f of x or is it f of g of x? Tan of log x. So I think you are saying this. You are saying that the first one is log of tan x. Second one is tan of log x. Let's see if these are right. So first let's look at g of f of x. So when you have g of f of x, the fellow that's inside will come on the left side, because x will first go to this. X will first go to the innermost function, and that innermost function will release an output, and that output will go to g, and then the final output will come out. So when you give x as input to f of x will give the tan of that. So tan x will come out as the output. And when you're giving tan x as input to g, then what will g do? G is a simple guy. G knows only one thing. Whatever input comes to me, I should do log of that input. When you say log x, you mean to say I should do log of that input. So log of the input will come out. If I'm giving tan x as input to g, then what will g do? G will give me the log of my input, and my input was tan x, so it will give me log of tan x as the output. So that's why g of f of x is this. Getting it? Let's see what f of g of x is. Because g of x is the innermost guy, put it on the left side. And what is g going to do? G knows one thing. Whatever input you give, it will give the log of that input. So here you are giving x as input to g. So g will give log x as output. Correct? Whatever input you give, g will give log of that as the output. Now this log x is fed into f of x, right? Because f of x, which is the output, is now going as input. Sorry, g of x, which is the output, is now going as input to f. And what is your f? F is a simple guy, tan x. When I say x, treat that x as input. So whatever input I give to f, f will give me tan of that input to me as the output. So if I'm giving log x as input to f, it will give me tan of my input, which is tan of log x. So that's how you get this second guy. Shall we test the same understanding with three functions now? Shall we test the same understanding with three functions? We can. Let's do it. Let's say your f of x is x square. Let's say your g of x is sine x. And let's say you have one more guy, h of x. And that is mod x. Let's say. And if I ask you what is f of g of, or let's say not f of g of, let me ask you what is g of h of f of x. So now I'm doing a composite of three functions. Usually in physics, you will not have problems where you'll have many functions as composite. Like that is typically a math problem. That is typically a JEE math problem. But you never know. You might get a case in physics where more than one functions, 3-4 functions are also being composited, and then you will have to find the derivative. So first you will have to understand what composite functions mean. That's why I'm taking an example for 3. So what is g of f of x? Can somebody tell me? Maybe you can't type that because there is mod and all also. But try typing if you can. I will explain you first. Follow the same pattern, guys. Take the innermost function. F of x is the innermost guy. So put f of x on the left side. Then you have, after f you have h. So then you put h. Then outermost is g, so that will come on the rightmost side. Okay. So first you are giving x as input. That is where you start the whole story. F of x is a simple fellow. He knows one thing. Whatever input comes to me, I should give the square of that input. Because when I say x square, treat this x square as input square. Sine mod x square. All right. Tejasri, let's see if that is true. So whatever input will go into f of x, that input will get squared. So if I'm giving x as input will get squared, and x square will go into h. H is a simple guy. Again, h knows just one thing. Whatever input comes to me, I have to give the modulus of that input as the output. Like I have to give the absolute value of that input. If -1 comes to me, I will have to give mod of -1 as output, which is +1. If 2 comes to me, I will have to give mod of 2, which is 2 only, as the output. So whatever input comes to me, I will have to do mod of that input and give it out. So if x square is going as input to this h, what will h give me? Mod of that input. So mod of x square. Okay. So Tejasvi, I think you made a small mistake. You must have realized your mistake now. That's why, guys, these can get very tricky. I'm telling you. Mod x square, right? And remember, mod x square need not always be equal to mod x whole square. Although for most cases they will look the same only. Uh, they will look the same because of the property of mods, but these need not always be same. Okay, I'm not able to think of a case right now where they will not be same, but be careful, be very careful with this, like follow the process right. Okay, mod x square, obviously modulus has this property, x square is equal to mod x whole square, you can say that, but you can't say mod of x cube equal to mod x cube, or maybe you can do that also. I'm not sure. Maths can get tricky. Okay, it's always safe to assume that they are not equal. It's safe to assume, because if they are equal, you will not fall in, you will still be good, like you would have done your calculations assuming that they are not equal, so you are more on the right path than assuming that they'll be equal. So mod x square will come as the output, and finally mod x square, not mod x whole square, this fellow will go as the input to g, correct? And g is a simple function. What does g do? G is sine x. So whatever, if I give x as input, sine x will come out as output. If I give mod x square as input, sine of mod x square will come out as output. So g will give me sine of mod x square as output. Okay. So what is the answer to the question that I had asked you? I had asked you what is g of h of f of x is, and that is sine of mod x square. Hello Vishnu, good afternoon. So guys, clear? Clear? Did you understand the concept of composite functions? Now tell me, how many such blocks can I line up? How many such blocks can I line up? At least can you answer this? Is there a limit to the number of blocks that I can line up? Is there a limit? Infinite. Yes, absolutely. Kshat, Tejasri, you guys are right. There can be infinite functions. So when I say, so remember when I was writing this law, when I was writing this chain rule, I was writing f1, f2, f3. I was doing that. No, I was writing something like f1 of, f2 of, so on, fnx. What do I mean by that? That simply means my first block is fnx. I give x as input to this. This fellow will come out, and this will go into fn minus 1x. And the output from this all the way, the final output will go into f1x. And then I'll get my, like, so it's like a chain of processing. That is what this function means. So the idea is, I don't want you to remember the formula for this. I want you to understand what chain rule is now. I want you to understand what chain rule is now. First, you have to understand what composite functions is to understand what chain rule is. Now that composite functions are clear, and now that the fact that you can line up as many functions as you want, and you can make a very complex function also, which is made up of so many functions inside. Now that this is clear, let's see what chain rule is. So I will first start chain rule with just two functions, like the two function form, you could say. And that is where did that thing go? Here. If you have f of g of x and you are differentiating this, first differentiate the outermost function and keep its input as it is, then differentiate the inner function. When I say dash, by the way, this dash means differential. So d by dx of f of x can also be written as f dash x. Dash is just the short form notation of d by dx of f of x. Instead of writing this, I can write this. So I can also write this as first differentiate f of g of x, then multiply this with the differential of g of x. So first take the outermost guy, just differentiate the outermost guy and keep its input the same. Multiply that with the differential of the inner function. Can we apply this analogy to three functions also? Okay, in fact, before applying this analogy to three functions, let's first get more clear with what this means for two functions with the same problem. Let's say my g of x is x square. Let's say my f of x is sine x. So guys, what is f of g of x? Quickly tell me. Quickly tell me what is f of g of x. Line them up. Line them up and tell me. Is it sine x square or is it sine x whole square? I would be happy if Akshat can answer this. Oh, Tejashri, no, I guess you are wrong. It's not sine square x. It is sine x square, which means it is this guy, not this. This is wrong. This is right. G of x is inside. No, put that on the left. Then put f of x. First feed x as the input. G, what will G do? G will square the input. Now x square is going as input to sine f of x. What will f of x do? Whatever input you give, f of x will give the sign of that input. Input is x square. So f of x will give me the sign of that input. Input is x square only. Okay. Input is x square only. So this is the answer. Please revise these things. Please practice them more. Because you are very likely to get trapped. You might feel that you have understood, but unless you practice these problems, you are very likely to write sine square x instead of sine x square. You are very likely to, instead of writing sine of mod x, you can easily write mod sine x, and they are not equal. If you write mod sine x instead of sine mod x, they are different. But you can I think you guys can clearly see how vulnerable you are to make a mistake here. So do practice this, people, practice this block method again and again. Now, fine, f of g of x is available with me. Now I want to differentiate this fellow. I want to differentiate sine x square. Okay. I know the formula for differential of sine x, and that is cos x. How do I know this? I know this from the 10 formulae that I gave you in the class. Correct? But did I give you a formula for sine x square? I did not. Then you will have to use these fundamental formulae and the laws the 4 laws that we have discussed. You will have to use one of these laws, or maybe more laws also. One or more laws, maybe one or more one or more formulas from those list of 10 formulae, and combine these to get the answer for this. So remember, you will need one or more of those 10 formulae, and you might need one or more of those 4 laws. What were the 4 laws? Sum or difference in differentiation, product in differentiation, quotient in differentiation, division rule in differentiation, and the 4th one was chain rule. So you might need more than one law also. Depends on the problem. Let's see here what do we need. We can clearly see the sine x square is a combination of two functions. It is a combination of gx, it is a combination of f of x. Don't think that in the exam they will give you g of x, they will give you f of x, and then they will write this, and then you will get an idea that okay, Sin x square is the composite function. No, you will have to look at sin x square and you will have to make this deduction on your own. Akshat is asking, sir, do we have to use the product rule here? A very common question, but a very common mistake also. No, you will not have to use product rule. You would have to use product rule if you had this. If you had sin x into x square, then you would have to use product rule, because this fellow is a separate function f of x. This fellow is a separate function g of x. So product rule is used for those cases where you have f of x into g of x. But do you have f of x into g of x here? No. You have f of g of x. What do you have? You have f of g of x. You don't have f of x into g of x. That is the difference, people. Be very careful. Now that you have realized it is not f of x into g of x and it is f of g of x, it is f of g of x. Now your brain should tell you, you should not use product rule, you should use chain rule. Because for differentiating composite functions, only chain rule can help us. So what does chain rule say? Since this is d by dx of f of g of x form, sorry, this is d by dx of f of g of x form, what do you have to do? First differentiate this outer fellow f and keep its input as it is, and then differentiate the inner function g. So what is the outer function here? What is the f here? F is sin x, correct, here in this case. So first differentiate the outer function. When you differentiate sin x, you will get cos x, correct? But will you write cos x? No, because your input will not be x. Your input will continue to be g of x. What is g of x? X square. So cos of x square will be the first term. So this term that you see, this term of the chain rule, this term, and will give rise to this. Okay. Differentiate f because f is sine. So differentiate sine, get cos, but don't write cos x. Write cos x square because the input is x square here. This f of g of x, this g of x is x square. So you will have to keep that g of x as it is. Don't make that input as x. And multiply this with differential of g of x. What is g of x? X square. How do you differentiate x square? Have I given that to you in the list? Have I given d by dx of x square in the list? Well, if you look at that list closely, there is a formula d by dx of x power n. And the formula is n into x power n minus 1. If I make my n equal to 2, I will get this. So d by dx of x square will be n is 2, so 2 into x power 2 minus 1, which is 2x. So d by d of x square is 2x. So although I have not given you d by dx of x square, I have given you d by dx of x power n, and you can use that to get this. Okay. So 2x is the output. So 2x is the term that I am looking for. So this into 2x. So I can say this red term is this 2x. Not 2 into, it is 2x. So guys, differentiation can get tricky. It can get tricky, very tricky, people. Because you have these composite functions, you have to take care of the fact that you don't change the input to cos x. You have to continue to keep it x square. Because there is an x square here, this x square has to carry. So many things. Unless you practice, just by listening to it, you're not going to get it. Yes, Tejasri, your answer is right. It is cos square into, the answer to this question is, the answer to the question is what Tejasri has written in the chat. D by dx of sine x square is nothing but cos x square into 2x. Okay. So today I took a lot of time to explain you chain rule, explain you composite functions. You can also have something like what is d by dx of sine of log x square. Now this is tricky, even more tricky. Why? Because this is like two functions, d by dx are three functions, f of g of h of x. This is something like that, right? Where your h of x is log x, where your g of x is mod x. In fact, these are four functions, not even two functions. Four. So remove the square for now, because I don't want you to start struggling with four functions. Let's look at only three. G of x is your mod x, and f of x is your sin x. I could have used four functions examples also, but first train your mind to look at this. Like, you should be in a position to look at this and identify h, g, and f on your own. Are you getting it? Are you getting where you have to reach? You should look at the combination of functions, and you should be able to individually pick what is h, what is g, what is f, what is inside what is inside what. You should be able to do that on your own. Okay. By the way, the answer to this question, if any of you want it, I've not given you the law for three composite functions yet, so don't worry. If you don't get it, it's fine. But still, the answer to this question is cos of mod of log x into mod of log x by log x into 1 by x. I know this is a lot of you will get more mind blown. Seriously, it's not that, it is this. The answer is this, because there is a mod also which you forgot to differentiate, right? So don't worry about this, people, because this is involving three functions, and I have given you the law chain rule only for two. I have given you only d by dx of f of g of x. I have not given you d by dx of f of g of h of x. Tomorrow I'll give you this also. I will start with chain rule for three functions, and then we will extend this understanding, the pattern that we have developed, we will extend this to n functions also, because you might have a question sometime, I don't know, which will have lots of differentiation. So I want you to get that understanding right away, even like right at this point only. So people, please continue to come live, please continue to ask your doubts in the chat box and answer my questions. Tomorrow we will extend chain rule, and then we will spend uh, a few more days only solving differentiation problems, like 2 days or something, and then we will be left with 3-4 days in this week, and we will try to cover 1D kinematics in that time. So that's the plan. Once we finish kinematics, we will end the bridge course for physics, and we will start with mathematics. In fact, I'm already covering some topics of mathematics right away, like this composite functions. It's not even a bridge course topic. It's a proper class 11th ending topic. The stuff that you have learned today, composite functions, that comes towards the end of your class 11th. And if you have a clarity on that right now, that's going to really help you, right? So we are already covering some maths topics while discussing physics also. So even if we fall short in time, we will still be able to cover a lot by the end of this bridge course. Okay. So thank you for joining in, guys. I'll see you guys tomorrow. Take care. Bye bye. Stay safe. Come live. Keep coming live.